Thanks for joining everyone to our final webinar of the year, Understanding Data Science from Data Chaos to Meaningful Decisions. Before we start, I would like to introduce myself. I am Belen Rocha, part of the Culture and Communications team from Beyond Tech. I will be moderating today's session, so feel free to drop your questions in the chat or in the Q&A session. And before we jump in, I would like to introduce today's speaker, Henry Gomez. He's a 23 years old software developer from Venezuela, who is currently in the middle of an exciting transition, moving from software developer to data science and AI engineer. He already has more than 7 years of experience in the tech world, working mainly with Ruby and JavaScript. And he is also an AWS certified cloud practitioner, and he's now on the path of earning his certification as an AWS AI engineer. So we are in very good hands today. Whenever you are ready, Henry, the floor is yours.
Thank you, Elem. Hi, everyone. Thank you all for joining this webinar today. I really appreciate you spending your time here. I want to quickly walk you through what we are going to learn in this session. We will start with the origin of the trend data science. Then we are going to explore the full journey from raw data to business analytics and data science. And we will see what are the methods used for data scientists to predict the future. In this case, we are going to see the difference between classics method, like traditional method, and the machine learning in a simple, but of course, a concrete example. And for close, we are going to work in a mini data science project that is pretty good. In this case, we are using an airline as an example. By the end of the webinar, my goal is that you don't just know what is data science, but that you have a clearer idea of how it fits into real projects and how you can start moving in that direction by yourself. So let me tell you before we start a little bit about my journey. So I started programming as a self-taught developer. I didn't grow up doing advanced mathematical, and outside of what I saw at the university, I never really had a reason to use things like statistics, linear algebra, or more formal mathematical concepts. About 2 years ago, I had my first real experience as a data science. I was in a company that approached to me and said that they need a model to predict student performance. So at that moment, I honestly had no idea where to start. My first instinct was just to build some SQL queries, calculate percentage, and build simple reports. So, but that was not what they wanted to work like that, right? What they actually needed was a full pipeline, collecting data from surveys in this case, cleaning and transforming it, and then feeding it into a machine learning model that could make real predictions. For me, that was a huge challenge because I had to face topics I basically were avoiding. For example, the mathematics, the statistics, Python for data, and machine learning fundamentals. I have no prior experience in any of that. So over the following month, I spent counted hours and plenty late nights studying and experimenting little by little. I was starting managing to build a modern end-to-end project from raw survey data to a working predictive model. So it wasn't fast or easy, but it was incredibly rewarding. So looking back, I know my progress could have been much faster if I had understood from the beginning many of the concepts that I'm going to share with you today in this webinar. So that's exactly why I'm here today, to make that path a little bit clearer and more accessible for you than it was for me at that time. And also, I want you to motivate to keep you learning in this field because this is a very good field that continues growing out every single day. So let's define some concepts before I start. You are going to hear me talk about artificial intelligence a little bit more in the webinar. So when I talk about artificial intelligence, don't think in ChatGPT, Google Bard, or something like that, I need you to think in artificial intelligence like the base layer of everything, because artificial intelligence is the base layer of machine learning, deep learning, and finally generative AI. So when you hear the word artificial intelligence, think of all of this, not just in generative AI, that is ChatGPT and Google Bard, for example. And also, I want you to understand this type of words. We have the word analysis that is most related to the past, is looking backwards to understand what happened in the past. And we have the word analytics that is looking forward to understand what will happen and how to influence it. Currently, in the current data science, we talk about analytics as a combination of both words, the past and the future. For example, if I say data analytics, I'm not talking just about the future, I'm talking about the past and the future. There are some busy words, but it's good to understand when you see this word in the webinar. So let's see at this chart first. This first chart shows the share of organizations that use AI in at least one business function. So since 2017, adoption has grown from around 20% to almost 80% in 2024. The purple line shows generative AI. So specifically in this case, as you can see, we have a 78% company using AI in at least one function. We are not talking about generative AI, just AI. Can be machine learning, can be deep learning. Um, so what I want to say that is that the message is clear. AI, artificial intelligence, remember, not ChatGPT, is no longer experimental. It's becoming a standard capability inside most of the companies. So this is not only a good to know. This is a very a thing that all the developers should know and should know how to work with this. So looking at this second chart, we can see the top specialized skill mentioned in AI jobs, in this case comparing 2012-14 with 2024. So skills like Python, data analysis, SQL, and data science have exploded in demand with growth rate of several 100%. For example, if we see data science has a growth of almost 100%. So we also see skills like AWS and even scalability and automation becoming core requirement. So if you are a developer today, these are exactly the kind of skills that will open the door to AI and data roles. So let's not talk more about chart. Let's check this quote that I do like a lot. Every second, humanity generates more data than existed in all of history before the year 2000, but data alone is meaningless. We need people who can turn raw data into decisions. That's where data science was born. So this is a very good quote, because data science is just about turning data that have no meaning in data that have meaning and the people can understand. So let's check a little bit about the data science origin, from where this term comes. So, when we talk about data science, it can sound like something completely new, but this root go back a long way. If we go back about 20, 25 years ago, most of the data people inside companies were statisticians. Their job was to clean data sets, apply statistical methods, and help answer business questions with just pure mathematical. As data started to grow and technology got cheaper and better, the role evolved into data miners. The focus for the data miners was just, let's dig into all this data and find hidden pattern. So this role needs to build new statistical models to get more accurate insights, because they were looking for patterns in data. So around 10 years ago, the same idea took another name, that is predictive analytics. It was still static and pattern findings, but now with a strong focus of predicting what will happen next. We are not just finding pattern, we are trying to predict the future in base of the data. So like predicting like sales, churns, risk, etc. And today we put all of that under one umbrella that is called data science. A data scientist is basically someone who combines what statisticians were doing 20 years ago with modern technology and, of course, code. So, if you took a statistician from 25 years ago, gave them Python and today's tools, they could easily fit into several roles we know now, like data science, machine learning engineers, data analytics, and so on. So, it's very interesting that that is the that is the starting of this role. So let's understand a little bit how is the workflow in a data science. So we will start with the data big data team. The data big data team is just a team that solve on doing the work, heavy work on the available data. They work is to collect the data, cleaning the data, and organizing the data. Um, the big data team, the data team, sorry, work with two types of data. The first type is the traditional data. That is just the data that we see day by day. It's like a structured and well-organized data, is low volume and manageable size, fixed schema and consistent types, and easily processed with conventional tools. So let's see this example. I probably most of you are familiar with it. On the left, we have a student table. Each row is a student, and the column ID is an unique identifier. So we can say that the ID one means Jim. On the right, we have the subject table. So in this case, so in this case, we have also an ID. In this case, we have 82, and this corresponds to the subject swimming that is taught by the person Wally Webb. Sorry, the subject is track. And in the middle, we have a grades table that is a combination of both. This table just connect both worlds. It has a student ID, a subject ID, and the grade. So this is traditional data. It's data that we see day by day. And this is how traditional data work. We design table, we define relationships, and then we use SQL queries to join and answer business questions if that's the case. And we have the second type of data that is big data. A lot of people will think that big data is just any database with a lot of rows, but this is a mistake, because a table with 1,000 or even 50,000 rows is not big data. What really defines what is big data are the famous 4Bs. Can be 6 Bs, 6 Bs, and can be 9 Bs. But for webinar purpose, we're just going to talk about the 4Bs. So the first B is volume, huge amount of data, not megabytes. We are talking about terabyte or petabytes. The velocity, the data for big data is coming very fast in real time or near the real time. We have also the variety, that we have the data in many different formats, not just clean tables. And the veracity. Data can be noisy, so can be incomplete or can be unreliable. So that is the job of the data teams to try to make the data the most accurate as possible. So if we see that this example here, this is like something that could be related to big data. We can have text, for example, logs for a server, document, report, chat message, that combined with image, video, audio, sensors, social media interaction. So let's think about like the database of Instagram. Instagram not just has a database with the users in a table. They have the videos that user upload, image, the social media interaction that they do. So that is a very good example of big data. So now that we understand and we know the type of data that exists, the job of the data engineer, the data team, is to prepare that data. They need to apply labeling, cleaning, transformation, and feature engineering. We are going to see what's about in the next slide. But here is a key point. Data engineering is not data science. Data engineers build the pipeline that data science will use to extract the meaning. Of course, there are some jobs position, and probably you can face with that kind of jobs, that you are data science and you need to extract the raw data, apply labeling, cleaning, and also use data science tool to predict the future. So it's not usual, but you can find that in the current field. So we're going with labeling. Imagine that we want to build a model that detects spam emails. Here on the left, in the left table, we have a small data set. This just is a text of emails, but there is no answer yet. As you can see, we have this email text that is you won $1 million. Is a spam? We don't know. The same with this reminder, team meeting tomorrow is a spam? We don't know. So here's where the process of labeling starts. Is when a human or a team goes through these examples and assign the correct label to each one. For example, for the first email that is you won $1 million, of course, this is an email. We just put the number one that is true. And for the second one that is reminder, team meeting tomorrow, we label this data as spam as false because it's a real mail. So this is mostly about labeling. It's just adding label to the data as a human because we are just looking as human and based in our previous experience. The second one is cleaning. As you can see, as the name said, this is one of the most important parts of data science. It's just taking messy, inconsistent data from the real world and turning it into something that is reliable enough to be used for BI reports or machine learning in this case. So without these steps, any fancy model we build in top will give us bad of misleading answers. So as you can see, this example in the left side, we have data that we have names in minus, we have names in minus and uppercase. We have in this case this age is good, but this person have the age in 20 years. This should be only a number. And for Michael, we have an age of -5. So what we are doing here is to clean those values. In this case, we put all the names in uppercase. We correct the age of Pam. For example, we remove chart, we remove letters. We only have numbers. And for Michael, we put 42. You will say, okay, why you put 42 here is because it's the number of life. No, it's because there is a thing on cleaning data that is inferring. If you don't have a value or if a value doesn't make sense, you can infer that value based on business rules or probably based in some extra service that can help you. How is that? Let's assume that the company says if you find a person without age, put 42 because that is the average age of the company and this is a business rule. So I can do that. Or they can say to me, if there is a person that doesn't have age or the age is very wrong, you can go to an external API and try to match that user with the name and last name, with the email, etc. And we are trying to find the values when we are cleaning the data. So it's like we always need to try to have the data most clean as possible and try to take all of our option to do this work. So after data cleaning, the next big step is data transformation. Cleaning, the previous step that we saw, is about fixing problems, but transformation is different. It's about changing the shape of the data so that patterns become easier to see for humans and for machine learning models. Here is a single example. As you can see here, we are doing data transformation. In the left side, we have country, we have price, and we have quantity, and we are converting that three column in something that has more meaning to the machine learning model. In this case, we created a new column called total amount that is just a combination between price and quantity, and we have country USA, country Canada as true or false because the model don't understand about words. The model also don't understand about if there is a relationship between price and quantity. So that we are just doing that, just changing the shape of a column. And now we have our last step, that is feature engineering. In this case, feature engineering is about creating new variables from existing data to make patterns easy to learn. It's very similar to transformation, but here's the difference, that with feature engineering, we're mostly focused on combining a bunch of columns to create a new variable, like we are doing here in the left part. We have a data set with monthly income, total debt, and age, and we are going to create two variables. We have debt to income ratio, it's just like a division between total debt and monthly income, and we have this age bucket that we are just going to transform the age into a string, saying, okay, so if the age is less than 25, is a junk, and so on. So this was the data team. After the data team complete his jobs, here's where the business intelligence team start doing his own work. So once our data is cleaned, transformed, and we have done some feature engineering, we reach a stage where the data finally start to contain insights. This is where the business analytics or business intelligence teams comes in. The goal of BI is to take all the prepared data and answer concrete business questions through dashboard, reports, and visualization questions. For example, which products are selling the most this month? The business intelligence team can answer that question, creating some reports in, for example, Power BI or Tableau. Which region is growing faster? The business intelligence team can create a report to answer that question. So business analytics doesn't necessarily build complex model. Instead, it focuses on describing what happens, tracking KPIs, and giving managers and teams the visibility they need to make informed decision. Remember that the business intelligence teams work in the past, work with past data. They are not predicting the future. They are just responding questions based on past data. And here is where the data science team starts. We already cleaning our data. The business intelligence teams already created some dashboard for the company. And here where data science team start. The data science team just try to use advanced analytics and machine learning to build models that predict future outcomes and help the business make better decisions. As you can see, data science work between the present and the future, and that business intelligence work between the present and the past. So, which technique use data science team to predict the future? The first technique is using traditional methods. Traditional method is just assessing future scenarios by using advanced statistical method. It's just pure mathematical. There are a lot of traditional method, of course, but for webinar purpose, we are just going to talk about the linear regression. Linear regression is a statistical technique for modeling the relationship between one output variable and one or more input variables. So let's assume that we have this data set. We have pilot, we have flight hours, and we have average residual speed. And what we need to calculate, what we want to calculate with the linear regression is to predict what should be the correct average residual value, residual speed based in the flight hours for each pilot. How the linear regression do this? The linear regression has a formula very simple that is y equals to a plus b times x. In this case, x is the flight hours, y is the value that we have, but we want the linear regression to predict what is the better value of that residual speed. So we also have the average residual speed, but a and b are values that we don't have for the formula. A control the slope. In this case, if the orange line that we see here go up or go down, that's the slope on the line. And the B parameter, that is the intercept, or also called bias in data science. Bias or the intercept is the starting point of the line. Is saying, okay, a pilot with 0 flight hours, I predict that should have an average residual speed between 9.0 and 9.5. So how linear regression calculates what is the expected average residual speed based on flight hours. These red lines are called residuals. The residuals are the difference between the data points and the prediction the line will produce. So why the linear regression need to find an I and B values? These values need to be found because this line need to be in a point that is nearest all the pilot. So this is the position of the line that is nearest all the pilot. So in this case, this also is calculated. If we square this difference, we get the squared errors. So as you can see, as the lines move up or move down, those squared errors become larger or smaller. So for example, let's see the pilot C that has a very big square, and the pilot B that has a small square. If we add up all the squared errors, we get the sum of the squared errors, of course, that is called SSE, which we use as our loss function. What is a loss function? Is like how far the algorithm is from the expected value, right? So the goal of the linear regression is to find the values of A and B that minimize the sum of squared errors. So the goal of this is to have to minimize the loss function, that it can trace a line that has that has less squared errors from all the pilot. So when this finish, when the linear regression finish, this can predict that in this case that the pilot B is the better pilot, because with the flight hours that the pilot has and the average residual speed, in this case is the best because it's more nearest the line, is more closer to the line. This is pure mathematics. We are not using anything related to machine learning. Okay, so this second method that we use here is the machine learning. Is machine learning. Machine learning is just creating an algorithm which a computer then used to find a model that fits the data as best as possible. A machine learning algorithm is just trial and error process, and each consecutive trial is at least as good as the previous one. A machine learning algorithm is composed by data, model, objective function, and optimization algorithm. We are going to see what is this. So let's assume that we have a robot and we want this robot to learn how to shoot with a bow. So our model is the usage of the bow. That's the goal that we want to reach. The data is a set of arrows, and our objective function is going to be calculating how far from the target was the robot when he's shooting. So if we give to the robot, for example, 100 arrows, the robot will start using the bow, is going to start shooting, and the objective function will say, okay, your first shoot was bad, the second one was good, and he is going to do that kind of things. And there is where our optimization algorithm starts, because our optimization algorithm is just a mechanism that will improve the performance. So it will say, okay, this shot was good, let's try to repeat this shoot with these kind of variables, or this shoot was bad, let's forget that shoot. So that is mostly the a machine learning algorithm is based on these four things. Even the complex one are based in the same principles, of course, with a lot of more calculation, but this is like the base of everything in machine learning. We have three types of machine learning. We have the supervised learning, that is the one that we are going to see more in deep in this webinar. And we have the supervised learning, and we have the reinforcement, the reinforcement learning. So supervised learning is just training a machine with data that we already know. We already know what that data is. So, for example, if I say to the machine, shoot this arrow, in the supervised learning, I know that that arrow is going to produce a bad shoot because it's a bad arrow. And if I give to the robot a good arrow, I know that that arrow is going to be good. So we're training the model with data that we know the values, so that the model can learn how to calculate, how to know if that arrow is good or bad as their own. We have there are two basic types of supervised learning. We have the linear regression, that is to learn the machine to predict a value. For example, let's assume that we want to predict if an arrow is going to be good or bad, and we in the linear regression. And we also have the classification, that is mostly teach to the machine how our data is going to be classified, because we are training the machine with a data set that is, this arrow is good, this arrow is bad. So the machine should, when a new arrow that it doesn't has a specific type, the machine automatically will know if that is a good arrow or a bad arrow. And the unsupervised learning is just passing data that we don't know what that data is. We don't know, we don't have similitude as a human. For us, it's we are not good on looking at similitudes on big data sets. So the machine will automatically find a pattern, and then they will start applying clustering they will split the data and will say, okay, this yellow point here are like this because they have this difference and these have another difference. But because the unsupervised learning is without human intervention, we don't know the values. We are just passing the data to the machine learning. The machine learning will automatically apply clustering to the data and will will return a result. And based on the result, when I start working and saying, okay, this group is are the yellow points, the group are the blue point, etc. And we have the reinforcement learning. So reinforcement learning is not giving chocolate to the machine, of course. It's just some extra points if the machine do something good, and punish the machine if the machine do something bad. I want you to see this video of an AI channel called AI Warehouse that is very good. He is training some machines with reinforcement learning to that they can start running and jumping from objectives. So as you can see, they need to put they need to pass like 15 tries so that the machine start really running. So they now need to now understand how to jump. As you can see, there is a lot of tries, so the machine need to understand. Of course, the reinforcement learning is something that take a lot of tries, but it's a very interesting thing, because with this we can even teach a machine how to do everything, because he's just iterating and making it workflow a lot better. To finish with the machine learning part, the data splitting is how we divide. If we have a data set of, for example, 1,000 data, we need to split this data in 70% is going to be our training set, is going to be what our machine with what our machine will learn. 50% will be the validation dataset. That is a dataset that we know the value, but we need the machine to work with that to see how accurate is the machine with that data. And the other 50% is for testing. It's data that we don't know the value, and we just want the machine to start calculating that. Okay, so before we start to see the real data science project of the airline, I'm going to open to the Q&A part. So if there is a question there.
Not at the moment. I think we can move forward. Remember, you can drop your questions in the chat or in the Q&A section.
Okay, so now we're going to work with a real data science project. It's very short, but it's very concrete. In this case, we are the data science team of an international airline that is called Beyond Airlines. Our mission is to predict whether a pilot is high performance or need improvement based on their previous flights. With this project, we are going to work in something called Jupyter Notebook. This is an interactive environment that will allow us to combine Python code, data visualization, and explanatory text in just one place. This structure made a lot of easier to guide a stakeholder through each step of the analytical modeling, and also to guide you to see what I am doing, which code I am running. So we are, and also we're going to use the following key Python libraries. We're going to use Matplotlib, that is just for data visualization, for chart. We're going to using NumPy, that is for doing complex calculations in Python. And we're going to use Pandas, that is for data manipulation. So the airline just has these three tables in their database. Their database is very messy. So we have the pilot data, the pilot table, we have the trips table, and also we have the aircraft table. Before we start with the project, I also want to explain to you what is a data frame, because this is a word that you are going to hear in the day by day in the data science workflow. Data science is just data frame is just a better way to handle data in Python. It's just like an Excel table, but in code. So with data frame, we can do merge, we can do joins, we can do a lot of things, but with Python. So for example, in this case, if you want to do this in in Ruby or in a framework, we need to go to the database, probably call the ORMM. But in this case, data frame is will help us to do this a lot faster. Of course, there is a tips. If you start using data frame and you love it, don't depend too much of data frame, because there are some things that is better to do in the traditional SQL. You are going to see what are going to what I am talking in a moment. So just let's focus on that. The data frame is just a good way to handle data in code. So let's start. I present this. This is Jupyter Notebook. As you can see, Jupyter is a good way that we can combine code and Markdown and text. So we can say, for example, this part is the part of the import, and this part is the part of the database connection. So in this case, we are connecting to the Beyond Data Science demo database. That is the database that has every table that I mentioned previously. We are going to see what is the content of that tables. Here I'm defining some utility functions. We are going to see what are each one of these functions, but for the moment, I'm just going to explain the first one, that is the real table function. In this case, with the real table function, what we are doing is to execute a query and select everything from the table, and we are converting the data that the database returned to us, the rows, into a pandas data frame. So let's go into this block. If I run this block, as you can see, I have the three tables here, but converted into data frame. So our first table is the aircraft baseline. That is just all the aircraft that the airline has. In this case, the airline has three aircraft. That is an Airbus, a Boeing, and the baseline speed nautical mile hours is the speed that the airline is expected the pilots to fly that airplane. Is the good speed that we expect you to fly. So we also have the pilot table, the pilot data frame. As you can see, this data frame is missing. For example, there are some pilots that have the flight hours, some none. There are some pilots that have the full name in minus, and there are some pilots that have the ID in 002, 004. So this is where the part of cleaning the data starts. Also, we have the trip data frame, and the trips data frame is just the trips that those pilot did. As you can see, we have a trip ID, a pilot ID, a route name, yeah, the origin, the destination, the aircraft, and the total speed that the pilot did on that flight. For example, the pilot with ID 2 in this route, in the Boeing 747, flew at the speed of 450 knots. And also, we have our first level that is high performance. So this data frame, this content was already processed by a human. So the human said, okay, by my experience as an aircraft manager, I think that this trip is high performance, because probably this pilot flew in a velocity closest to the expected velocity or even less. So in a while, we just see what we are going to see with that values. So now that we have our data into data frames, we can start working with this. We are not doing any more SQL queries. We are just going to work with data frames. So we start our part of cleaning the data set of pilots. As you can see, I'm going to explain this in deep, but what we are doing here is cleaning the pilot ID column, creating a new temporal column called pilot ID clean, and we are applying to the pilot ID column of each rows. We are applying this only digit or none. That is just is a function that is defined here in the utility function that I mentioned before. For only extract digits, no letters or something, because we don't care about letters. We only want digits for the pilot ID, and we are just applying this function that is integer safe, that is to avoid to Python to raise an execution error. And we are just doing the same with the fuel name and the same with flight hours. In this case, for the fuel name, we're just applying title case and collapsing spaces. And for flight hours, it's the same as it's a numeric value. We are just getting only digits or none. So here, if we were not able to clean the full name or the pilot, because the column were very, very messy for that specific pilot, we are going to drop that pilot because we can work with a pilot that doesn't have an ID, and we can work with a pilot that doesn't have a name. So if the data, if we did or good a good chance to try to clean the data and still we were not able, we can just drop that row. And finally, we are just renaming the columns. In this case, to pilot ID clean is not going to be pilot ID, full name clean is going to be full name, and so on. As you can see, this is now our data frame, is way beautiful. All the names now are in the correct format, or the pilot ID also in the correct format, and the flight hours are also in the correct format. Doesn't have letter or weird characters. And here we are doing just the same, but with the trips data frame. We are just cleaning this trip data frame to have better data that we can work on. As you can see, this is the result of the cleaning the trips data frame. It's just the same, the trip ID, the pilot ID, the origin, destination, the aircraft in now in new case, the total speed nautical mile per hours, and the high performance. So we only left, as you can, if you can compare this the original data frame that has things that, for example, route names, etc. There are some columns that we don't care about. We just care about this column because these are the columns that will help us to predict if a new pilot is high performance or not. So now our data is clean. We have two beautiful data frames that we can work on. So we are going to start the feature engineering part and the data transformation part. We are going to start with the pilot. We are just we are just creating a new column called rank, and this column is just going to be based on the flight hours. As you can see in the slide of the webinar, we are just doing here. If the pilot has less hours than 50, it's a student. If has less than 200, it's a co-pilot, and so on. As you can see here, we are just creating a new data frame with the rank. We are doing just the same with the residual speed calculation. Here it seems that cursor is doing some correction. I don't know. So in the residual speed calculation, what we are doing here is to creating our first feature engineering variable that is a subtraction between the total speed of the trip, that is the speed that the pilot currently flew that plane on the trip, and the speed that we are expecting that pilot to fly that plane. What we did here, we just transformed our data frame into a dictionary, a Python dictionary, so that we can map here the aircraft of the trip data frame into the corresponding speed. So this is very simple. This calculation is just a subtraction, as I mentioned. As you can see here in the result data frame, we have the baseline speed. That is what we are expecting the pilot to fly. If we compare this manually, as you can see, this pilot flew the Boeing 747 at 4,115 nautical miles per hour, but we were expecting this person to fly this aircraft at 420 nautical miles per hour. So this left us a residual speed of negative 5.0. So if the pilot has negative values, it's because are flying height faster. If the pilot, like this, for example, like this pilot has a residual speed of 20, positive 20, this person is flying slow, is flying 20 point slow. So we can say that that person has some need to take an eye in his job because it's very slow. Of course. Now we are now that we have the trips data frame with the column that we want. In this case, we are just creating some simple column like the rank, like the residual speed. Now we're going to normalize these two data frames in just one data frame, because if we want to pass two data frames to a machine learning or to a traditional method algorithm, it's going to be messy. So it's better to have like just one data frame with all the data that we care about. So what we are doing here is just combining the trips the pilot data frame inside the trip data frame using the pilot ID. As you can see, this is very similar how we join tables in SQL. So that using data frames, using pandas, allows to do this kind of things. Our resulted data frame is this, is a one big data frame that will include the trip ID, the pilot ID, the pilot name, the rank of that pilot, the origin and destination of the trip, the residual speed, the flight hours, and the high performance. So we can say that we just merged the pilot ID inside the trips data frame. That is the one that we care about, because it's the one that is the data that we need to use to calculate future high performance values. So now our data is clean. Now we have a good data frame that we can start making prediction on it. But first, I wanted to show you what the business analytic part will do in a real case, in this case using Matplot. Um, as I mentioned, the business intelligence is just about answering questions. So if our boss say to us, which pilot shows the best performance based on the residual speed. For example, as I mentioned, flies faster than expected. Using Matplot, I can create this kind of chart, and I'm going to see that Liam Johnson is our faster pilot because has a residual speed of less 30. We can also a reply question like, how does flight experience, flight hours, relate to performance residual speed across the pilot? So here we are trying to get a relationship between these two columns. As you can see, the pilot that has less hours, in this case, Liam Johnson is a very good pilot because has less hours and has less residual speed. But this Olivia Brown that has 0 flight hours has a residual speed of less 20. Or this Mia Thomas, for example, has less than 2,000 hours and has a residual speed of 0. We can see that the pilot that has more flight hours, in this case, has less residual speed. So we can also see how is our pilot team distributed by rank. We can see we have 3 first officer, 3 co-pilots. So we can do a lot of things with Matplot, and also as a business intelligence, that is a very beautiful role. We can create dashboard, simple dashboard charts, or you can even work with Python to show to the person how is the data. So this is for getting a better visualization of the data. And now that we already explained the past, we already do our charts related to the business intelligence part. Here's where the data science part really start. As a data science, probably, I hope so, if you want to work on this field, you only will work predicting the future, because it's the real work of the data science. But here, as problem with human resources and problem with the roles, there are some persons that are hired as data science, but they need to do also business intelligence part. So it's good to know this part. If you are going to learn about data science, it's good to know everything on the field, even if you're not going to use it because you have lucky. So, okay. We're going to start with the traditional method. As I mentioned, for purpose of the webinar, we are going to use the linear regression equation. This is very simple. I'm not going to talk about technical details and mathematical details that are very complex, because this is just going to get us bored. I'm just going to try to explain this code in the most simple way. Here we are just the same, obtaining the data frame. As you can see, this is our data frame. It's just pilot ID, pilot name, rank, flight hours, and average residual speed. Why are not getting all the data frames? Because I don't care about the other columns. In this case, for this traditional method algorithm, I just want this kind of column that are the columns that will help me, that will help the equation to predict the average residual speed. And here, as we saw in the slide, we have the X, that is the flight hours, and we have the Y, that is the average residual speed. So how do we calculate the B and the A? In this case, we are calculating this using NumPy's polyfit. That this is just, this polyfit is generating a lot of polynomials based on the X and Y values, and will choose the polynomial that has the less value. It's the same as I mentioned. This is calculating the loss function, so that we have a loss function with a very minimized values. So this result here will give us something like this. For example, we have the intercept that is -3, and we have the slope. If we want to say, okay, but what are these values? The intercept is the default value. So this based on x and y, this equation, this polynomial equation is calculating that for a pilot that has every value in zero, for example, the flight hours in zero and the average residual speed in zero, should have a average residual speed of -3, and is saying that every time that x value change, for example, every time that the flight hours augment, the average residual speed is getting modified -0.0076. So these are the prediction of the linear algorithm of the linear regression. That is just the intercept and the slope. As you can see, is mathematic, of course, but it's just mostly of the same. Here I'm just creating a new column called predicted residual. That is just the formula that we saw in the webinar, that is a plus b times x. And here we can calculate the distance to line of each pilot. So what is the distance to line? It's just the average residual speed subtracted by the predicted residual. If we see this visual example, this last data frame, for this Emma Smith, the average residual speed was -5, and this predicted that this pilot should have a -11 residual speed. So the distance to line for this pilot is 6 points. As you can see, Liam Johnson has a better distance, a far away, more distant to line. Why? Why if Liam Johnson was a very good pilot? As you can see in our chart, we can see that Liam Johnson has 2,000 flight hours and has a average residual speed of less 30. But in this case, or linear regression algorithm is calculating that this person should has a less 4 points of predicted residual. So the distance to line is 27 points. In this case, our best pilot is Sophia Wilson, that has the less distance to line. We are going to see this in a better example. As you can see here, the start of the line start below zero. That is starting is less 3.12. This is the start on the line, and the line for every change in x is going down at 0.076%, as I mentioned here. So this is the linear regression algorithm, and with this we can predict the linear regression will predict the expected value for that pilot to have an average residual speed. So the linear regression is merely for predict a value, and it's mostly for know, okay, who is better, who is more closer to the predicted value, and we can have in this case the best pilot, that is Sophia Wilson. Okay, now we are going to see what is a machine learning algorithm. As you can see here, I divided this by the 4 steps of a machine learning algorithm, that is data, model, loss function, and optimization function. For data is the same, is our data frame, and this is the data that I'm going to use to train my my machine learning model. And here I'm just adding some average of the values just to have the model to be more accurate. And here is our model. So what is our model doing? Our model just have 2 functions. One is called sigmoid, and the second one is predict probability. Sigmoid is a mathematical concept that is to convert real numbers into 0 and 1. Just that. Why we are using sigmoid? Because this machine learning model need to classify or pilot into is high performance or is not high performance. So it needs to predict to give us a probability of high performance to each pilot. So with the sigmoid, what we are going to say is, if the machine say I am 0.70% sure that this pilot is high performance, we are going to convert that into 1. Is high performance. It's not. It is no. It's high performance because the sigmoid is just doing that, just converting from real numbers into 1 and 0. So don't care about
if you don't understand this concept, even it's very simple. And we have the predict probability. This function is just calling sigmoid, and sigmoid is going to be called with this with this parameter. This only parameter is just the xt vector, that is just our x design, that is our data frame, and we are combining this with a weights. Here we are obtaining a matrix product, that a matrix product if the multiplication of two matrix. Okay, it is quite is quite hard to understand. So I want you to explain the weights, because let's assume that x design, the xt parameter, is just our data frame. Let's assume that is our data frame, and the weights is like the importance that the machine is going to put under all the variables. So let's run this and let's see some real example models. So for example, as you can see here on the first call that we did, we just the x design value is just like this. So for example, we have the first value is the bias. So the bias is like the opinion of the machine. In this case, is set to 1, so it's neutral. And here are the values that we are putting to the here, these are the values of the flight hours of the first pilot. Here is the average residual speed of the first pilot, and so on. So our X design are just vectors based on our data frame, right? So how our loss function work, how our this loss function works. What we are going to do here, this is just a function, we are not calling the function. We are going to pass the vectors based on our data frame. We are going to pass the y and the weight. So here the y hat, we are going to predict the probability, the first prediction of the probability, calling the predict probability, that is our function in the model. And this will do our first prediction using the weight set to the main values that are these, set to 0. So then we are going to calculate the loss. So how far the machine was from the original value. So how far with the first calculation the machine was for the real value, that is high performance 1 or 0. And depending on the loss value, we are just calculating here for loss, sorry, this is something called the binary cross entropy loss. Is a mathematical algorithm that will help us to predict these kind of things. As you can see, this is very similar that the linear regression is doing, but we are doing something similar, but with machine learning. And here, when we already have our loss, we can predict also the gradient. So this is what will help us to, as you can see, we are returning the loss function is returning the loss and a gradient function, and this is going to modify our wake. So for example, in the optimization function, as you can see, we are going to iterate 1000 times the loss and gradient function with the same data frame. And this will automatically, as you can see, this automatically will calculate how the weights are going to move. So if the machine in the first try is very, very far for the expected result, he's going to try to find, okay, I need to move X, I need to move Y, because the machine is going to, I'm not saying to the machine anything, I'm just passing the data. This algorithm is automatically optimizing himself. As you can see here, in the iteration 0, the loss was a 0.69. So the machine was a 0.59% far away from the real value. And these are the weights that the machine is. These are the grading values that the machine is used. Like let's negative 0.5, negative 0.17. So as you can see in the iteration 100, the loss was a lot better. In the 200, the loss was a lot better. And our final weights are this. So the machine is like tracing a relationship. In this case, is saying, okay, so every time the X value, that the flight hours move, the average residual speed is going to be modified by a less 4 points. So This is like a concept that was very hard to me in the first time, because I say, okay, how a machine learn, how a machine can understand what to do with the data, is because this is pure mathematical and vector. So the machine is automatically for iteration is just calculating the weights, and this weight I can use this way in another model to calculate the same, and will be the same, because now my model is already trained. So for example, if I do 10,000 iteration, as you can see, our loss is better and our gradient values are changed. So every time the matching interval is better, the weights are getting better, and we're going to have more accurate results. So as you can see here, we are using the same data set. So of course, the matching is going to be very good predicting this data set, because he learned based on this data frame. As you can see, he's predicting that this pilot that we know that has a high performance of 1.0, he's predicting that the probability of high performance is 99%. The same with this, he is super secure, and with this person, he is 0% that is high performance, because he automatically detected that this person is flying slow. But what will happen if we pass to the model a new data frame? As you can see here, I'm creating the data manually. This person doesn't have label, they just have flight hours and average residual speed. Here I'm just doing the same. I'm normalizing the values, and I'm calling the predict probability function that is our model. And as you can see, our result data frame is just the pilot names, the flight hours, the average residual speed, that is the one that I calculated here, and automatically the machine is calculating that this person, for example, based in the flight hours and the average residual speed, is 90% sure that is high performance. And with this person that is flying slow, is 0.21 probability that is high performance. So this is mostly machine learning. Of course, this is a very, very simple model. This not even something that you will use in real life, because you can calculate if a pilot is high performance using linear regression. But the purpose of this is to understand, at least what I want you to see, is that how the machine learn. It learns based on mathematics. It's the same with ChatGPT, with Google Bard, of course. In this case, we're using 2 dimensions, that is the X, that is the flight hours, and the Y, that is the average residual speed. But for more heavy models, they can use even 100 or 1,000 dimensions, something that for our brain is impossible to calculate, but the machines can work on this. So just to finish this part, the machines learns based on vector, based in models, and of course based on iteration, that there is just trying to find out some relationship between the values. And now that we have the final weights, this is something that we can, for example, import in source files or import in some database, and we can have already a model trained to predict if a pilot is high performance or not. So let's open to the Q&A in this part of the project if you have some doubts.
We don't have new questions. We have a previous comment from Josue that the presentation is great. It's great for people to see how AI actually works and what it is. So it's very valuable content.
Yeah, that is something that I say. So how the machines learn, probably we are storing something in a database or something like that, but it's pure mathematical. And I recommend you to see something called a RAG, that is Rasterized Augmentation Generative, that is something called Talk with Your Documents, that is passing your documents from PDF to a vector database. So automatically, if you made a model that understands you, you can say, okay, well, what I did in my last reunion, and they will say, okay, last reunion, I'm going to find this PDF that is in this side of the vector, but that is just, it's mathematical. It's not something, it's not magic, just mathematics. Okay, so now that we closed this part, just for finish, I'm not going to grab you more time. Here is some tips that I want you to share with you. In this case, there are some tips that I just want to know when I started with this. If you want to start in the data science and start in this machine learning and AI field, I recommend you to start with Python basics. In this case, variable types and operation, control flow, functions and modules, and try to work with the right environment. So, for example, Jupyter notebooks, understand how to configure Python in VS Code, and also to understand core data libraries, for example, NumPy's or Pandas. My second advice is like something that we as a developer has like is not important, but is building the mathematically slowly. I recommend to start with the basics, try to understand what is an average, the percentage, the distribution, the formulas. Use a lot of visual to understand. As you can see in the linear regression example, I used a lot of visual, so you need to understand, okay, what is doing this, why this variable is changing to this. So try to build the mathematic slowly and without pressure because it is quite hard. And for the end, I will left you some tiny project that you can experiment by yourself. For example, Netflix show clustering. In this case, it's just grouping similar shows using k-means. You can build unsupervised machine learning. Spotify audio feature analyzer is another. And you can also build a reason scanner using NLP. NLP is natural language processor. So if you still feel uncomfortable with ChatGPT, for example, you can try to build your own ChatGPT, and you can just make your Python code to talk and to understand using some libraries that are already created for Python. Okay, so don't know if you have a question related to this. If there is something that I can help you with some advice.
We have one more question from Freddy. He's asking, how can I practice ML if I don't have experience or a strong math background?
Well, so that is a very interesting question because so if you don't have a strong math background, you at least need to understand the average or the few primary concepts. So it's very hard to practice machine learning without mathematical because you are going to do nothing. But you can start with the traditional method because all the machine learning algorithms are based on mathematical formulas. There is a lot of mathematical formulas, a lot of statistical formulas. So I just recommend to start doing things with traditional method. In this case, linear regression or classification. There are the logistic regression, that is the name of classification. They are the most simple traditional method, so you can understand what is happening behind the machine learning. Just start with traditional method, and then you can move to machine learning. And the same with business analytics. If you are a person that doesn't have a technical background, mostly of the business analytic person are not technicals. They are just know how to work with Power BI, with Tableau, and they know how to respond the correct answers. So just for not grab more time, I'm just going to show you this surprise. Remember that I mentioned that based on the weights that my model generated here in this part, I just exported these heights to a JSON, and I created a very simple Python project. So here, if you enter your name and your age, automatically we are going to generate some simulated flights for you, and our machine learning algorithm is going to say, okay, based in your flight hours and your average speed, we are going to say if you need improvement or not. In this case, my pilot need improvement. So if you are lucky enough to find a pilot that is high performance, for example, like this is random. This green button called generate license is going to be activated. So if you click it, you are going to have like a special certificate that will certificate you to data science learning license. So you now are certified to start working now, start learning as a data science. Don't think that with the license you are going to fly a plane. No, it's just for data science. So I'm going to, I think that Belo shared the link here. And yeah, you have there your certificate, and that is. I hope you like the presentation. I hope you understand that a little bit more about this very beautiful field. So when I started in this, I was feeling fear because I say, okay, the mathematics is going to be very rude. And I don't even understand, like, I start programming by myself. So this is a very good, is a very good moment to start understanding this. Now that we have the machine, the generative AI like ChatGPT is very more, is going to be more faster to us to understand, because we can tell question, etc. So it's just that lost the fear starting in a new field. This field is the future. I'm not saying that the developer, we as a developer, are going to die, but it's a very good opportunity to start learning it. So, I mean, in Slack, you have also my email. If you want to talk to me, to explain something, we can also build a project together. If you want to build with me some project of the one that I mentioned in the example, let's do it. And well, I hope you have a great time with me. And I hope you don't get too much bored with the mathematical. Thank you.
Thanks a lot, Henry, for your time and for crafting this amazing presentation. Before we go, we have one final question from Luis. He's asking, how do you think the role of data science will change with these AI Asian trends?
Yeah, so I think that in this case, the role of data science with all the AI trends is going to be, I think, that more accessible. As I mentioned, I was able to start as a data science in a very single way from being a developer. So I think that using generative AI and AI is going to make the data science role better. We are going to have more powerful algorithms and will be more accessible. So more person that like me that started from self knowledge without, like, I didn't study statisticals. Of course, if I want to be a very good data scientist, I want to predict some things more high, for saying like that. I need to study a lot of statistics, but you can start with the AI. You can start at least starting in the field. So I think that at least for data science is a very good tool. It's a very good tool, and it's going to power what data science do. It's not like a tool that will steal our jobs. It's just going to make more powerful what you are doing and to generate value, because data science is just like that. It's to solve problem, to generate value, don't respond answers, because what we want is to a company to don't go into red numbers, because we want the bosses to understand, okay, if you do this, you're going to have this kind of money, this is going to be good, this is going to be bad. Data science is just, yeah, like that, answering questions, predicting the future, and doing it in a very good way. So with AI, I think that we are going to be more powerful.
Thanks a lot. I think that was the final question. Thanks again for crafting this presentation. For everyone who wants to revisit the content, you will find the full recording on YouTube, in our YouTube channel. Thanks for joining. I hope you have an amazing day ahead, and see you in the next webinar.
Thank you all. See you.
Bye-bye.